All right, well, it's 12:05, August 17th. I'm here in Spokane, Washington, and we got Eric Dollard and the crew on the call today. Just going to do a quick announcement on just two different websites. Do this screen share. So the main website is, I did have it up right here. So this is emediapress.com. This is where all the video presentations and books are. And this year we took I took off. Not going to be doing the conference this year. This is so my company can focus on product development. But this is where you can find a lot of the presentations from the conference, other presentations, and digital downloadable books, and other presentations from Eric and everybody else. This next page right here, EPD Laboratories, Inc. is a 501c3 nonprofit corporation, and it survives by your donations. And if you go to ericpdollard.com/donate, and also there's a donate link in the main menu bar, that'll take you to this page here. Most people donate by PayPal. You can do a single donation or a recurring donation. There's even a Bitcoin address. And then if you want to send a check or money order, here's the address right here where you can donate to EPD Labs by check or money order. And when I receive those, I just endorse those and send them back down to the bank in Nevada. And this helps pay the bills. This pays for projects. And if you go through some of my blog posts, a lot of the other live calls with a lot of the slideshows that Eric and Haka says and Griffin and Justin and Connor has shown, you can see that these donations are definitely going to the, furthering the work in this field. I guess in general, you could say furthering the science of electricity. And there's quite a few experiments, and the magnitude and the scale of a lot of these experiments are larger than anybody else is doing in the world right now in the entire field of Tesla-related research, and at least what's publicly shown. I'm going to end this slideshow. Let me change the view on my screen here. So Eric, I think you're already unmuted. Is there any, let me let some more people into the room here. I don't think Adrian's going to be joining us on this call, or Bruce Gavin, but we do have Griffin Brock today. We have Haka Says, we have Connor Fisher, and we have Justin Miller, besides Eric Dollard and myself. So if you want to go ahead and take it, Eric, anything you want to, any announcements or start it off with, and then we'll have a couple slideshows with Haka Says and Griffin.
Well, mainly the Heaviside book is done, so that was quite a multi-year effort. What it is basically is a continuation of the Lone Pine book, getting more into the mathematical details and what have you, and it's a companion to the presentation that I gave on that subject, which I believe was called Electromagnetic Induction and Its Propagation. So that was quite an effort to wrap up. What basically the next step is what I'm doing is I'm writing up my last two presentations, the one on Tesla and the one on Bach. So one chapter at a time. So the first chapter of the Tesla four-phase presentation, I believe, is already out. And Griffin has all the material now to put out the second chapter. So presently I'm working on the first chapter of the music presentation, which is the one on Pythagoras. It's turned out to be quite interesting. I don't think anyone has done such an extensive analysis of the Pythagorean coordinate system. Not that anyone would even know what it is. So I've been finding that quite fascinating to develop. So that will be the next one coming out. So I'm in the process of writing that chapter now. I would estimate it will probably be done Pythagorean section will probably be done in about a month. And then it'll take probably another month to get it transcribed and out. And I'll be continuing to zigzag between the Tesla presentation and the music Pythagoras to Bach presentation. So that's the ongoing project here. Something that has gotten to the point where I'm starting to become quite angry. I virtually have no more tolerance for this digital technology and the artificial malevolence that goes along with it. I'm finished with it. So the thing that pushed this is a lot of work was put into the opening part of the transcription of the Bach fugue. The website will not allow it. The other thing, a lot of work was put into getting the first sounds of the musical seismograph. Digital will not allow anybody to hear that, and they will not allow anybody to hear the Bach. So I'm finished with this digital shit. The only way to get this stuff out now is to put it on a CD and sell the CD for the cost of producing it. So I'm recommending that as a next step. No more digital. So there's nothing I can do. If it doesn't work, it doesn't work. And I'm not going to continue to beat the dead horse of digital and play its silly little game. I'm done with digital. So that kind of pretty much wraps up what I'm presently working on. And there's quite a bit of other stuff that needs to be transcribed and published, but it's just the manpower involved and what have you. I don't know if it'll ever get done, but over a period of about 4 years, I accumulated roughly 1,000 pages of notes, transcribing the works of Steinmetz and Kennelly and J.J. Thompson and what have you. But there's simply no manpower or funding for that project. So it's done physically. Griffin has all the copies, but it's probably won't happen in my lifetime. And I believe Griffin has begun now on the ELF receiver. This is a completely out of the ordinary receiver that will receive from DC to 30 cycles per second. It's basically, its purpose is for the advanced seismic warning system, which, because of the twisting and tweaking that's going on around the San Andreas Fault right now and spreading out to other parts of the country, there is more interest in that. So basically, I'll turn it over to Griffin and see what he has to say about that.
Yeah, so the amplifier that's currently under construction was configured by Eric himself. Over a decent amount of time, we were able to produce a design that is suitable for my current means. Now, unfortunately, the images that I have ready for this presentation that display the amplifier have not been procured at the moment. There's a buffering stage, so I can merely just talk about it at the present. But as Eric said, that the characteristics of this amplifier are peculiar in the conventional sense. It will allow for the forecasting or the detection of seismic precursor signals, which from Eric's experience and other talks and what have you, he's stated that this is a very possible realm of research and could be conducted quite so. These signals, usually depending on the magnitude of the preceding earthquake, will have a reasonable signal or strength, which could be detectable at a great distance. And by using this means of amplification, we could ultimately receive those signals and record them hours and possibly days prior to an event. Now, granted, my current location within Southern California, this type of research is very crucial and will definitely find suit in any other research that will present itself going forward. So going aside from the amplifier project, I've also been experimenting with furthering the 1A21 radiating beam tube, which, Aaron, if you have the images for this slideshow, if you could possibly show them and I could elaborate on them. Branching off from the previous live calls and previous articles that I have published on my findings with the radiating beam tube, as it's pretty much a replication, although an improvement on Nikola Tesla's original X-ray tube design, I have found some peculiar properties with such a tube, but I also have found realms in which it can be improved further. Now, in the past, I've touched upon the efficiency of this tube and its overall lifespan as being rather limited to only about 30 to 50 hours of workable operation. Now, of course, this limited longevity is partly due to the fact that the vacuum within inside this tube, as you can see a portrayal of before you, is impaired by residual water moisture as well as other contaminants found within this deep or hard vacuum. These contaminants are liberated during the operation and during the initial testing of the tube as a high potential is applied to the electrode. And this liberation essentially contaminates the electrode as well as the interior workings of the tube and shortens the lifespan of it subsequently. Now, the only way to get around this without placing any other unnecessary electrodes within the tube, which could impair its operation, would be to employ a getter. Now, in the classical convention of vacuum tube fabrication, a getter is a metallic substance, usually made of barium or other metals such as titanium and aluminum, which absorb these water contaminants and other particulates. And by doing so, you could essentially allow for the vacuum to maintain constant and maintain itself over its overall working period. So currently I've been experimenting with different designs of improving this tube and how I could go about placing a getter inside the tube to increase the longevity of it. The difficulty presents itself in that placing any heavy metal within this tube could ultimately lead to the manufacturing of higher energy X-rays, as the characteristic X-rays produced in any X-ray tube, for that matter, is proportional to the element of the electrode material or whatever the accelerated particles bombard into. So that's something that we want to mitigate. Now, by doing so, I've leaned towards a pure aluminum getter as an experimental means of collecting these contaminants. And from my research thus far, although minimal in this regard, I have found a suitable getter size and a suitable placement with relation to the electrode. And as shown in this experimental vacuum tube setup, we see that the getter is placed behind the electrode so that all the activity and the projected matter emanating from the electrode and also intermingling with the vacuum within inside of it is projected away from the getter, so that the getter really has no influence on the emanations from the tube. And this was verified by the experiments thus far. Now, to take this tube to the next level, it would also be necessary to experiment with removable electrodes so that to further increase the longevity of the tube, as well as placing other pieces of metal and other samples directly in line of the radiating beam for further experiments. And this could be easily accomplished by the setup as shown before, where we have vacuum clamps and vacuum flanges made of glass and other dielectric materials, which could allow for this type of experimental setup to occur. In my line of research, using metallic clamps severely augments the performance of the tube. Thus, we have to lean towards dielectric materials for such clamps. This tube design has yet to be constructed, but based off my experiments thus far, it will be a likely candidate to increase the longevity of the tube. Next slide. And looking at the clamp that's at the other end of the tube, furthest away from the electrode, we see that this is essentially a front portion of the clamp in an experimental setup where we could ultimately have what is emanating from the electrode and within inside the evacuated envelope, that it could be projected out into open air by use of a window or a small metallic opening, which of course is highly experimental, but in my line of research, this is very possible. Now, the purpose of doing this is that the projected particles, or what have you, that are emanating from the tube could be experimented with open air with little attenuation and could extend themselves at great distances. And this will afford for analyzing the emanations from the tube and further analyzing the operation of it as a whole. So this is a rather simplistic setup, but what's behind it is a massive amount of engineering and arduous experimentation because the window material has to yet be determined. Likely it will be a very lightweight material of an incredibly thin thickness. And of course, the size of it still has to be determined, but the overall design or construction remains the same and is most likely going to be as such as you see on the screen. Next slide. I'll go to the previous slide. And this is a side view of the front clamp as you just saw on the previous slide and the assembly. Now we could see that the envelope is essentially a flange, a vacuum flange that's comprised of glass and the cap that corresponds with it. And of course it's secured by clamp number 1 made of a dielectric material. Now in coordination with what I was expressing earlier, by experimenting with what we place inside this tube, that is placing any type of material we wish that will essentially be bombarded by these particles or what have you, we could likely see some rather interesting phenomenon occur that's akin with other experiments that are being conducted at large particle accelerator facilities, when in fact this could actually be done on a small benchtop setting. And in this hypothetical situation, we could take the already removable cap that comes off the top end of the tube and secure a small sample or an experimental piece which we wish to bombard with the particles emanating from the electrode and essentially see what occurs. There are a multiple of possibilities that could come to fruition from bombarding the sample with these particulates. So it's still up for grabs as to what will occur, but nonetheless, the energies that we're working with presently will definitely lead to some interesting results. And branching off this realm or this scheme of experimentation, we could go to the next slide. We see that this type of experiment was actually expounded upon sometime in the past. So an Italian inventor in 1909 took out a patent for a similar method of experimentation in which he used cathode rays of the like we are currently using to bombard an experimental sample of an unknown material. And he reported, without getting into further detail, of some interesting anomalies and other phenomena that occurred by bombarding these samples with cathode rays. Now, mind you, he was working at very low potentials, specifically on the range of 10 to 25 kilovolts of accelerating potential. And of course, it was direct current, whereas we're working with high frequency impulse currents. So this is merely an example of what could be done in this scheme of bombarding cathode rays, of bombarding targets with cathode rays. So it's a very interesting realm of research that still has to be explored, but thus far, I mean, the hypothetical possibilities are practically endless. So that's what I'm currently working on, aside from all the other projects as well, the book transcriptions, the amplifier projects, and what have you. So I see that this will definitely lead to some interesting research down the line in the near future. And that's pretty much all I have to add. So I
got a question.
Okay.
So how do you activate the getter?
The getter, as here, if we could go back to the previous drawing here, Aaron, thank you. So we see that the getter is affixed to a lead-in electrode. The getter in this sense, from what I've found by experiment, that if I have a sacrificial piece of material, while the tube is on the vacuum pump, I could excite it with the same high frequency, high potential means as the electrode is connected to, and by doing so, that getter will be saturated with all the contaminants and essentially render the vacuum rather pure. So this will alleviate the electrode, the main electrode, from absorbing most of the contaminants and be able to operate in a more efficient way. So it's essentially a sacrifice. That's the main principle of this getter, because any other forms of getters involving flash getters or non-evaporable getters of that kind, that will ultimately introduce quite a few complications as far as I have found. But then again, it could be a viable solution. That has to be experimented with. But thus far, having a
So basically, what you're doing is you're using one electrode as, and that eats up what is going to attack the main electrode. Is that correct?
correct, yes.
Okay. So the early vacuum tubes used magnesium for the flash getter material. I don't know why they picked that over aluminum, but maybe that's something to consider while you're doing this.
So the problem I've experienced with magnesium is that it has a tendency to sputter, or it deposits a magnesium coating with inside the glass more readily than any other metal, such as aluminum or what would it be? Titanium. So magnesium wouldn't necessarily be preferable if we were to use it as a sacrificial piece, but then again, that still has to be further explored and quantified. So
Yeah, that would make sense because those magnesium getter tubes from the primordial days, you couldn't see the inside of the tube because the entire bulb was silvered.
exactly. And
Now,
I've
the other
constructed
thing I noticed is you don't have the bulb on the end. That's not necessary.
what I've found is that there is a critical distance or a critical length to the tube, and by proportioning out the diameter of the bulb to the length of the tube, you could get away with this configuration that the tube length would actually be significantly shorter as opposed to the current 1A21 tube designed with the bulbous end at one point. So I found that the diameter also has to be about a quarter of an inch larger than what is currently used. This is all very experimental, but I found that just by balancing the tube length with the bulb diameter, you could get away with this.
Okay. So you have to come up with a modification to the tube numbers. So now you got a 1A21A.
Yeah, I mean, this is only one of the designs I've been experimenting with, so there are 5 other different designs that are highly experimental and still have to be constructed, but because
But it's still up in the air then. You don't have a,
right. I'm
okay.
for this design, I'm merely going based off the experiments I've done thus far, which will most likely lend itself to a successful outcome because this is really going based off of some rather simplistic principles that I've proven will work.
Okay.
So that pretty much covers the development of the 1A21 thus far. And I'll hand it over to Hawkins of nothing else has to be added.
I think we're good.
Okay.
So recent updates that I have, first to set the stage was the recent trip that we took to Tonopah, where we hit a certain level of completion with the antenna field Alexanderson system of successfully receiving signals from that system. The good side of this type of system is that it has very low noise, very good characteristics overall. The downside being that it has to be done in the desert, a long way away from civilization, a long way away from power lines and any other sources of interference. So go to the next slide. Well, anyway, there's 2 different methods of doing this, which is this large field, but there's also another, we'll say, competing technology that was popularized by Steve McGreevy somewhere around the 80s, 90s, and 2000s, which uses an electrostatic antenna on a relatively short whip and handheld system that amplifies the signals the same types of signals that are picked up by this Alexanderson system, but in a much smaller, more compact, simpler, cheaper system. The downside being is that you also have to be pretty much in the middle of nowhere, and the general quality is not as good as the conventional. Well, anyway, I'll talk in pictures. So the other system being by Steve McGreevy as a competitor is much smaller, more compact, but it has lower performance characteristics overall. What I've been experimenting with lately between long bouts of day job work is trying to replicate and make improvements to his receiver such that the noise characteristics are low enough that these devices can be operated in suburban and possibly even urban environments.
Are you able to see that?
Yeah, there we go. So that's Justin holding one of the old McGreevy device receivers out at the Tonopah field, and you can hear very much the same pops and crackles that you hear from the conventional system that we were testing. So next slide. I'll go back to it. So anyway, my work has been improving and experimenting with the McGreevy system. My original theory being that most of the designs he had ended in the 90s and early 2000s that were built with Radio Shack components. And my initial thought was that using more modern circuitry, more modern JFETs, and lower noise amplifiers, that we might be able to make some decent improvements to the system. In addition to that, in addition to the improvements to the receiver was also improvements to the filter networks that he used in a relatively simple manner. That was it was good for the part count and good for the overall system, but still lacked some level of noise filtration. For example, the location that I'm testing for my workshop has some high tension power lines, medium tension power lines, and underground cables, such that my shop is electrically extremely noisy, and the only thing you can generally pick up is a 60 cycle hum. So it was a perfect testing environment for this. So what I ended up discovering was it is showing up. So that's the Steve McGreevy's BBB4 schematic of the late 1990s that I originally based that I originally started from as a springboard to build from. Try next slide. Anyway, so what I found was I ended up discovering a technique that's normally used for operational amplifiers, which is a Sallen key filter, which is essentially a relatively strong high pass filter that I managed to apply directly to the input end of the JFET to create yeah, that's the breadboard, some of the breadboard work that I was doing initially. So what I discovered was that using McGreevy's really good design as a springboard, trying to make incremental improvements to it, I found a combination that was able to have an extremely high noise rejection for the 60 cycle power line noise that we have locally. So I was measuring characteristics somewhere in the range of like 60 dB reduction, which is pretty crazy given the characteristics. So so combining that with a few other factors, combining that with a 3-stage Butterworth bandpass filter, I was able to get extremely high reduction on the noise characteristics and have a system that's basically the next generation McGreevy. The reason that I'm working on this side is because it's a multi-pronged approach. Not only does it give us potential for setting up more sites and allowing amateurs to do their own EPD labs like seismic experiments, forecasting, listening to the ionosphere, things like that, but it also has a side benefit of being useful in a lot of other preamplifier circuits that we're working with in the shop and other fields. For example, the actual seismic mine could benefit from this exact systems as a higher performance pre-filter and preamplifier than was initially deployed by the university.
Any particular image you want? It seems to magically be.
Try back one. And so this was the performance characteristic of one of the later tests that I was performing. And it's kind of hard to see, but the white trace was a sample signal injection that was applied, which is 1 volt peak, 1 volt per division. And on the other end of the filter, the 60 cycle, the blue trace that you see in there is 1 millivolt per division. So 1,000 to 1 reduction, and you can still barely make out the 60 cycle hum on that. And then when you turn the frequency up to the bandpass cutoff is about 1 to 8 kilocycles, which is perfect for what we need. When you tune up to about 2 to 3 kilocycles, which is the peak band, the dB loss is only about less than 1 dB. So it has really good characteristics overall. Unfortunately, I got carried away to work when I was continuing, but even working out of a suitcase, I managed to finish one of the designs and ordered a couple breadboards. So I'm going to end up soldering a couple of these in the hotel because it's in such a close stage to completion that I really want to see how it performs in the real world. So I'm going to be busy with a combination of work and working on this stuff. And hopefully within the next few weeks, I should have a system that is that's viable for fairly mass replication and eventually able to put on the store or make available to other experimenters that want to listen to Earth signals and the same things that we're working with. So that's all I have for right now. I'll try to do a longer presentation, more thorough explanation of the filter design and all of the components of this when I get some free moment, but that's what we got for now. Sneak preview.
Okay, so I guess are there any other slideshows? I think Justin might have some stuff to share.
Yeah, thanks, guys.
Okay, go ahead. Go for it.
All right, so what I wanted to show was some of the historical overview and what happens in a work episode. And as we shared on recent calls, you guys have seen some of the major progress that was made in terms of actually terminating wires receiving signals at the shack. So we've seen some problems with slideshows here thus far. Host has disabled. Aaron, if you would enable my screen share. See if we can.
Should be able to do it now.
There we go. Go in here. Trying to anyways. If I go view full screen, does that show up for everybody?
Looking good.
All right, great. Hopefully this will roll for us. So just overview, there's a lot of slides. I'm going to move quick. If anybody has any questions, don't hesitate to interrupt me. But condition of the shack, we've shown this is going to be redundant, and that's part of why I'm going to move fast. But want to show the condition of the shack. This is a rare shot. What this represents here is prior to the issuance of our right-of-way. So we're just visitors at this time. We were instructed specifically not to alter the shack at this time. So when we finally did receive our right-of-way, this is what we received. We received a damaged facility that had a lot of dangling parts and a whole lot of cleanup that had to be done. This photo series is pretty much in series in terms of time, moving oldest to newest photographs, but there are some funny things, and one photograph snuck in here that doesn't belong in here, which is right there. That does not belong in this series of photographs. But again, showing the condition, and you can see the difference. This is when we were visitors to the facility, had not yet obtained a right-of-way, and then by the time, several months later, that we obtained our right-of-way, this facility was really ready to blow off the hill. So effort number one was simply to secure it, and that's what I did initially in 2014. Like I said, these are slightly out of sequence, but pretty close. As you can see, there's no door. There's no way to enter this shack. There's no mast. There's no antennas. We're just involved in a cleanup. As soon as we obtained our right-of-way, we had to clean up the mess and the danglements. And I threw a couple of photographs, again, out of sequence. This is shop fluorescent fixtures. Back to the shack and initial right-of-way cleanup, you can see the amount of trash. I mean, that's just one truckload that we removed. But I felt it was appropriate just based on the the recent successes that we've had to just do a bit of a historical overview. So like I said, moving real fast here, we had to figure out creative ways when we had a pole that was hanging by the cable TV messenger cable. How exactly were we going to remove that? And we came up with a clever way of guying it into the bed of the pickup truck. I had broken these out into a series of albums, but in putting them into this Macintosh iBook, it's made them all one file. So excuse the little bit out of sequence. This is the bench. I think we may have moved on to, I wanted to show an overview of the last last 4 sessions that happened, starting with January into February of 2023, because that's when we really, from this era until 2023, there were other people that were involved and I was not involved, but I came back into this project in 2023 to begin the shack revision or continue the shack revision from where you had seen it previously. So this is January 2023. That's the vehicle that I was using at present, the 1992 Toyota. And this is the condition of the interior of the shack at that time. You can see that various people have provided us with a ham radio setup, which is 2-meter radios and a tool cabinet. And we've discussed this is the APRS weather station and the 2-meter voice repeater radios that are in there. Nice equipment, not really configured in a very robust manner. So the effort was to rebuild, take this apart and make it more robust, rebuild it in a more robust fashion that would be appropriate and up to specifications. It's no more than a week after I got to the lab in January 2020, our associate Mickey went to the hospital, never to return again. And this is the picture of Mickey outbound. We barely were able to cross paths and work together. Very short period of time. So he's gone now. Eric had to take him to the hospital. And like I said, that was the beginning of the end of Mickey. So I'm alone now and beginning this work episode of 2023, which there were 3 month-long work episodes in 2023. And that's really what has allowed us, built the foundation for what we've been able to achieve this last session that we conducted in June into July of 2024. So buckets going outbound. Every time I would go out on this particular work episode to work at the shack, I would bring back rock to fix the drainage in the backyard. And I just began in structural retrofit. There was no block line, so the rats had access into this structure. Had to add block line in the roof, strengthen the roof. Again, hauling rock back, bucket loads. The most I was able to haul was about 12 bucket loads. And then wanted to show that in the evening time, the work didn't stop. It continued inside in the evening, beginning to put the new rack assembly together that would be more appropriate, as I had mentioned. So here's an example of the rock getting dispersed. And there's a lot more of this stuff to do. I just added this in. It's non-technical, but it's obviously, really part of the whole operation is to keep the facilities moving in the right direction so we don't get mired in the mud. This, I'm going to try to show a video at the end of this slideshow, and I don't know if Zoom will allow that. We'll give it a try, but this is a key critical component of this whole shack retrofit that we have conducted. And this is the ground plane, the RF ground plane. This is provided to us by Hakasez for this specific purpose, hence now installed. But this picture is prior to its installation. We're still just dealing with the internal structure. You can see now the so-called rack has been removed back at the shop on the bench. And we're beginning to actually put this into the rack and figure out our antenna configurations, move forward. And like I wanted to point out with a photograph like this, just really shows that the work episode does not start. It just it does not start at 9 and it does not end at 5. We continue on with long hours to be able to make all this stuff happen in the duration of a month. And as you can see, it was cold up there while we were continuing the construction process. This is just, purely carpentry phase at this point. We're just putting doing structural fix, insulating, installing the RF shielding wires we've discussed. The masts that we had were not really appropriate for our purpose. We wanted to add more structure. So you can see the blocks screwed on the exterior of the building, blocks inside the wall cavity to accept the mast that we installed. There's the mast attached to the shack. So, in a single day, we managed to accomplish quite a bit. This is the beginning of the retrofit of the dead end pole at the shack at the hilltop. And it came together quite quickly, and it's also quite complicated. There's a lot of pieces that went into that. End of the day, hauling back another load of rock. And as you can see, if you keep at this, it's slow and it's arduous and it's labor intensive, but it works. And just keep on at a snail's pace, bucket after bucket, day after day, it starts to make an improvement. Just another picture of this process coming together. The construction is nearly done for the inside. Fabrication of antenna mounts is ongoing. You can see a good example of the complete construction chaos that ensues. Tiny space, lots of intricate parts, and lots of aspects of this. Now, this is the rack, again, in the evening time retrofit, starting to come together. In particular, we were looking at the back of the RF ground plane bulkhead on the rack. And that's what we interface with that RF bulkhead on the outside of the shack. Weather station, 2-meter radio, dead end pole behind that. Dealing with the weather station, and we still have improvements to do on this weather station. I'd like to take this little white cabinet. I had to remove it to flash it and seal it properly to the building. And we'd like to actually move that equipment that's in that little fake white cabinet. We'd like to move that inside, but that's another detail. It's not really critical at the moment. But the larger hole you can see to the left, set that up with the proper slope so that could be flashed and permanently weather sealed to accept the RF bulkhead. And there it is installed. So that's starting to become a legitimate interface outside of in and outside of this building. And then to really carry that the rest of the way was this RF shielding wire that needed to be installed floor to ceiling and the floor and the ceiling. This is a picture of the wall material now going up over that. As you can see, the building's insulated, and these ground tabs were provided to have a direct connection to the mesh such that they would penetrate the wall material and we could access those tabs for our grounding purposes. And there's the RF bulkhead installed in the wall, and you can see up to the right of that, I don't know if you can see my cursor in the call, but there is the main ground lug. There's actually 3 of them on this plywood seam that ground the rack, and that'll be shown later. Just moving through the construction process. This January to February episode, I think this is about where I left it. Yeah, that's where I left it. This was just Eric and myself during this episode. So a good work episode always ends with a run to the dump. And believe me, there was a lot of construction debris from this phase. And then this was the episode where I actually hauled a load up to Spokane and brought that to Aaron's shop. So that was a great opportunity for me to get to connect with Aaron. That's what the load plus my gear looks like. And took this shot just as I was leaving the yard that session. This is February 2023, and there's always more to do. Like one of the things we talk about quite a bit is organizing this shipping container, because basically I found that the tools, the parts, the facilities needed to build that rack, retrofit that rack, were on hand. The real challenge was locating them. That was the real challenge. So I just popped this picture as a kind of final picture. And that gives a sense of a 1 month, what happens within the course of 1 month of an EPD Laboratories work episode. And that's just with Justin on hand. That's not even adding the additional crew, which the next picture here, this is me inbound to the lab with a utility pole that I acquired from near my residence, a place I was renting at that time. And I procured this pole and hauled it down to the lab, and we promptly installed it. That was the last pole that we had needed to install. So the work episode really with everybody, this is now June into July of 2023. It started off at the mine. And as you can see, digging. This was our, we didn't have our terminal poles or customer poles at the mine yet. And we had tried to hire a contractor to do this, but we ended up doing it, Eric and I, the old way. As you can see, Hawk Says and Griffin have now arrived, and they're beginning to work on the telluric end of things, while Eric and I are working on the excavation and creating clever ways to remove obstacles because we don't have hydraulics. Coil coming together simultaneously, telluric platform coming together. This is something we've covered before, but I felt like in the course of this sort of overview, going back over this again, the challenge of a brand new pole that was acquired for the purpose, purchased for the purpose, brand new, delivered to the lab. We found out that it was considerably, probably more than twice as heavy as the old desert dried poles that we have previously installed. So we had to get quite creative about even loading or handling this pole. It's kind of unusual, you know, it's unusual to see a setup like that where somebody would haul something that weight on their Toyota pickup truck. But that's how we've managed to get a lot of this done and also do it with, you know, such minimal cost, basically. Is I like this picture. Shows the different elements of things that are happening all simultaneously. You know, there's a lot of moving parts when we go out here and do these work episodes, and that's very satisfying because it's you know, a lot gets done and people are working on independent things, but also as necessary, people collaborate. So this is the first attempt at trying to stand this pole at the mine, which actually failed. And we had to do a lot of earthwork to get the truck in there level, get this thing sort of try to slide it in there. And then we found that we weren't able, with the manpower we had, to get this thing in the air. So we had to get creative. We had a weather event that happened during the course of that. But ultimately, with the apparatus shown there, we were able to get that pole in the air. Simultaneously, the platform was completed and tests were conducted, and that's been shown by other people in other calls. Here's a near final detail was the floor RF screen. And actually at this point, the other gentlemen are gone, and the two Steves, Steve McGreevy and Steve Young, are on site as the rack is, you know, partially disassembled and loaded to be taken to the shack for installation. And there is the beginning of the shack, the rack rather, installed in the shack. Steve McGreevy and Steve Young there. At the same time, we had managed to succeed with the crew in getting our customer poles up. And you've seen that in recent calls of the work that Connor did to provide the backboard for the power service at the mine. That's the power company's pole center frame, which was rebuilt to Eric specifications. And we've talked some about the next steps with that. Meanwhile, I continued on with the shack power system upgrade. You can see this is that sort of trapezoidal toolbox that was provided by some of the ham radio guys for the battery box. And that, you know, worked out okay, but in the interest of getting everything in the rack and getting it mill spec, this was I think this is probably an oscilloscope case that I repurposed for the battery box. There's the battery in its box and the rack. Antenna going together on the mast. That's the 2-meter voice repeater rate antenna. Pretty good representation of that round of things, you know, put together and pretty well finalized. And then that's the end of the session, July 2023, and this would be the beginning of the session, October 2023. We started off with demonstrations of the mine, which has been shown previously. And I'm skipping around, I'm moving really fast because there's literally tens of thousands of photographs and images from all of these episodes. And it's tough to decide what to actually show to to illustrate the story. So that's all I'm going to show of Griffin and Hakases from that episode. They've demonstrated that, various people have demonstrated other photographs from that episode, but this is continuing on what transpired after they left, which was, more line preparation, organization of hardware, modification, structural stabilizing of the final, of one damaged pole. There was quite a bit of fabrication then that had to go into all this outside plant. So this is October into November of 2023. Shown this wire before, but I wanted to show it again as one of the things that eats up so much time is in not having the right materials and having to go and reuse something like this. As you can see, that would be quite complicated to harvest that and reuse it. But with quite a bit of perseverance here and the right equipment, right enough, we were able to put this section of line up and actually get something that's terminated to the hilltop. And right at this moment in time, this is when Connor showed up and was able to assist us immediately in this fall 2023 work episode. So significant difference. It's not, it starts to compound when you've got a crew like this and they've got all their own equipment and redundancy of equipment. Things start to actually be able to move pretty quickly. And we were able to get this section of open wire lineup, still not, completely terminated in reception equipment at that time, but we got a huge amount of work done, and Connor really expanded his line work ability, got out there and just went for it. And we were able to get a huge amount done, grounding network out there at the terminal cabinet pole. And again, we're just running through trying to give an overview of historically what has happened, and then also hopefully giving people a sense of what happens within the course of 1 month. This was all work that was carried out October into November of 2023. And at the end of that session, we actually were able to have a demonstratable unit at the cabinet. And Eric has seen here some video that we've displayed previously of actually being able to take some measurements and do some reception from this location, from this cabinet. So that was a huge success right there in November 2023. In addition, we had a very favorable meeting with our landowners and began the process of renewing that right of way, which has since been completed. This picture represents the first picture of this last work episode, which was beginning in June 2024. And this is where we were able to make at last the final termination to the shack. That's the biaxial connector that allowed for a pair in a single coax to be terminated through the RF bulkhead that was shown earlier, which is ultimately connected to the 37 Bravo, which we've demonstrated. This session, I did something unusual. I brought this ATV out, which proved to be very useful and very fuel efficient. So I like that. That worked out really well to haul this thing. We had a considerable savings in fuel this way. Now, it wouldn't work out if this was the only vehicle because we still need to haul the ladder. So I did have also, Connor's pickup truck until he left. And then I had my diesel pickup truck in addition to this little vehicle, but this worked out quite well. One of the things we've shown in the last call was we did show the long range reception that we were able to do in the middle of the day, approximately 54 miles out. And this is just a fun picture of Eric, the dog, and myself going out to do that reception demonstration out of the PRC 47 that's shown there. And this is the configuration for this round. As we've discussed, the antenna ends at this point at this terminal cabinet and is transformed to a transmission that is then received by the 37 Bravo at the shack. And as we've also discussed, this is only Rev 1. We're intending to put a second 37 Bravo at this cabinet in tandem in the upcoming session to provide a large amount of the gain. But for this setup, this was, sorry, that diagram is blurry, but that's a diagram of the configuration there. And then this is the moment in time Haka says Connor and myself were able to at last connect this up and demonstrate that demonstrate the signals on the 37 Bravo. And we also discovered that the 2-meter radios interfered with the reception. So if the weather station reported while we were attempting to listen to the signals, it would overload the receiver. So I believe that Hawkstess is now left, and Connor and I got back on with cleaning up just some of the details, damaged facilities. As we've described previously, this is quite an extensive facility. Here's a little bit more of what we talked about last time that I hadn't really prepared to show some of these photographs, so I thought I would include them quickly, of taking down from the power company poles, removing some of the old damaged coaxial cable. We've talked about this at length, but this was, I think, I forget if it was 3 or 4 or how many days we spent out there between taking all of this down, rolling it up, moving the phone line to the appropriate poles, terminating wires correct, so that we didn't have any danglements, or we're ready to now work with the public utilities here to get this hooked up as Eric specifies. So that's Connor, I believe. Yeah, that's Connor on the pole. Well, that's me climbing. Connor is the ground man. So again, just demonstrating that there's a huge benefit to having multiple people. You can't do all of this stuff. You can do all of this stuff, but just one man or a couple of men. But it gets exponentially easier, I would say, more efficient as you have a team, have a crew. So this is the coax that we were able to clean up, just remove it. It's unused, it's unnecessary. We had secured it in previous years, but it was in the way and it was unsightly to the power company, kind of a nuisance to them. So we got rid of it and got rid of this damaged section of telephone line, again, to eliminate hazard. Connor got to experience the wire reeling machine. It's a bit of a blurry photograph. I should have grabbed the one after it, but shows the shack on and working at dusk. Connor and I were here to experience the signals do in fact increase coming out of the 37 Bravo at this hour of the day, which was what we expected. And it was great to be able to see that. Now, this is the first time that Eric arrived at the shack to observe this himself. And Eric determined that what we needed was an RF filter in association with this 37 Bravo. So we went about stripping a piece of equipment. Eric found a piece of equipment that had the suitable components, designed a circuit, showed me how to strip the appropriate parts, and instructed me, basically held my hand to the point where I could build what was necessary for him to come in and make these connections. And that was quite satisfying to be able to, work with Eric on the bench and learn directly from him in that fashion. Here is the completed RF filter with its biaxial connector ready to go in a panel. Panels machined, found a panel that was painted and looked appropriately like the 37 Bravo. And here it is going into the shack. And I had to make one more biaxial connector with the appropriate length on that cable, which I really didn't want to determine until I was at the shack. So I was able to bring this whole setup up there and make a cable inside the shack, which is quite satisfying. And there is the RF bulkhead with the 2-meter radios and the biaxial connectors coming out to the right. And you can see what looks like a little bit of frayed insulation. It's not. It's actually the braid that I had harvested. I had to custom make these cables because it's unusual We didn't have a cable that had a biaxial cable that had a braided outside shield. So we had to basically make one, an interface. And maybe that'll get improved in the future, but it's good enough for now. And then we got on to here we're at the other end of the line. Good overview of what we have as our intended total reception structure back to the shack. And we're starting to do some documentation, but also finishing out the last bit of coaxial, securing coax cable that's, as I said, unused, and also working on our grounding network at this time. And I think those two pictures are slightly out of sequence, but that's all right. Grounding network, documentation of the line. Eric and I were able to go pole to pole and do a complete demonstration of this facility and of this line. And that was about the end of it. I think this is my final trip up to the shack. You can see removing our smaller ladder and just in general cleaning up. I washed the walls inside the shack and just tried to leave everything as neat and tidy as possible. Cleaned up a bit of the rat debris that was around the shack and tried to remove any fire hazard from around the shack. So that's about the end of the episode. And then I had gotten on to some less glamorous tasks that just needed to be done, like finalizing the rebuild of these fluorescent fixtures, which was something that Mickey had begun and was unable to complete. So there are lots of challenges I won't get into with rebuilding old junk, but it was important that we carry that forward, and we did. So there's now a set of bench lights on the main metalworking bench inside the lab. And then here's a picture of the bench and tool cabinets across the riggers bay, which at the end of the episode you can see is in chaos. There's quite a bit of material that had been moved out, and it's unclear whether this is an electronics bench or whether this is an electrical contractor's bench or a telluric bench or exactly what's going on here. But my final efforts were in organizing all of this and making sense so that the facility is ready for whatever the next episode. Whoever shows up next is going to have a clean work surface to begin their work. And this is the end of the episode. That's what it all looks like on the truck. So that's the back end of the flatbed pickup truck that has hauled all of this apparatus out. And I'm quite pleased with all that. That worked out really well. And that is the end of the slideshow. I think everybody gets the point. That was really what I wanted to share. And at this point, I could turn that back over to the group for any questions.
So this is the video presentation Eric was talking about, which is related to the work of Oliver Heaviside. And the book number 3 that Eric referenced is in relation to this. And this is what Griffin has helped to recently transcribe. I have the final Word doc draft of this. There's just one word I have to remove a letter from, and then I'm going to attempt to upload it to Amazon, and hopefully it doesn't mess with the formatting. But the part 3 of this book, let's see, I want to bring up Amazon real quick because yeah, this right here.
There's part 1.
Yeah, so this is part 1. Part 2 is also in Amazon, but these are also available as digital downloads on emediapress.com. So you can either get an instant PDF download on emediapress.com, or you can come to Amazon and get the paperback. To find this on Amazon, I just typed in Heaviside Dollard, and that was the first result. And then if you scroll down, it'll recommend this. This is part 2. So part 3 will be going up pretty soon. As soon as I get it uploaded to Amazon, I got to go through the virtual book viewer. And if that looks good, then I'm going to order a proof copy for me and Eric so we can go over the phone any last details that need to be edited. And if it all looks good, then it'll be available as a paperback on Amazon and also as a digital download on emediapress.com. Eric wants to see all 3 books in a single volume, like a trilogy in one single volume. we'll look at doing that maybe a month or two down the road, just so that nobody gets confused about it, that everybody who already has one and or two who might want number three by itself can get that. And then we'll put all those into one volume. And again, that'll be available as a single volume trilogy with all three parts on Amazon, and the same on emediapress.com as a digital download. So that'll be coming pretty soon. And I think that's the only thing. Oh, and I just wanted to mention, okay, so again, you can see that the slideshow that Justin showed, this is a monumental effort. I mean, this is a massive, massive amount of work by multiple people. And this has been going on for years. And you can see that the donations that come in, absolutely go to, furthering this work. We actually need more donations. And what a lot of people don't understand is, besides donations, Eric spends quite a bit of money out of his own pocket with some Social Security money and whatever else, to help make it happen. And we have a certain amount of donations, in the bank and in PayPal. This covers the bills. It pays the rent, or not the rent, but it pays, property tax. There's insurance. There's money for the property that we have the right of way to. Where you saw these antenna lines, I think we have probably about 1.5 miles of property, that spans from one end all the way up to the shack, and then there's the mine, and then there's these telluric projects that you see next to the building, with the Alexanderson type of antenna. So there's multiple projects. That this is, Eric and Justin and Connor's kind of joined the team in the last year or so and has been very helpful in moving things forward. Haka says, Griffin Brock, I saw one picture with Stephen McGreevy and Steve Young. I've been down to Tonopah a number of times myself over the last 12 years. Been kind of busy in the last, year and a half. I haven't been down there, but anything that anybody is able to donate, or if you want to support this work, share Eric's page, ericpdollar.com/donate. And if you come to this page, you can donate by PayPal. There's an option for recurring donations, whether it's $5 a month or $100 a month. Everything adds up and it all helps. Once in a while, we'll get a $5,000 or a $10,000 check. They're few and far between, but they do save the day. And, if anybody is in a position to help with, $50,000, $100,000, we can make rapid, a lot more progress, a lot quicker. Short term, one of the things that the public is going to be able to take part in is some of these signals are going to be streaming on the internet, in one way or another. And this might be some type of subscription service that you come to the website, and for a reasonable monthly fee, you can actually tune in to what kind of signals are being monitored for the seismic type of, forecasting system. And that's going to be one, revenue generator that's going to be coming out pretty soon. So keep your eyes out for that. Also, if you want to send a check or money order, the address is here. That comes to me here in Spokane, Washington. And then I endorse those checks and money orders and send them down to the bank in Tonopah. So you can see that, it takes not only a lot of manpower resources and parts and labor and everything, but it's also fairly costly. And anything that anybody can donate helps. And please spread the word. There's all these interviews people can look through. You can direct them to my YouTube channel. You can direct them to Eric's website. Griffin has been helping to post some blog posts. This video that Justin was trying to play, that'll be available. We'll just, it'll either go on YouTube or it'll be embedded in Eric's website on a blog post or something like that. And I think Griffin also has a couple videos that are going to be on YouTube and or directly uploaded to Eric's website. And we'll be putting out posts about that. Let's see, I'll stop the screen share here. Any final words, Eric? And I'm going to see if anybody has questions.
A lot of things I should add. So
Okay.
basically, the Heaviside material is an extension of the common language for electrical engineers. So that has been an ongoing project since I started it in Lone Pine, when I ended up landing there as a refugee with a sabotaged car. After Landers got destroyed, everybody fed on me and made sure to put me out of commission for good. But the LA Department of Water and Power cooperated with me and made sure I had a place to park my car and what have you. And then we worked together. And I decided at that point that everything was gone. I was completely destitute. And I was a refugee, fortunately given refugee status by a premier utility company, which helped a lot. And of course, I helped them a lot. So I decided, being a feral human again, to completely restructure the entire language and mathematics of electrical engineering from scratch, with no reference books, very little any external material at all, and then work it up until it concluded with this third volume of the Heaviside book. So basically, the pictures that you see on the covers of these Heaviside books are actual lines. The first one is our line in the Mojave Desert that we rebuilt, which we've talked about. The second one is the California Electric line that goes from Bishop to Riverside through Owens Valley. And then the third one is the LA Department of Water and Power million-volt DC line. So the text of the books deals with the actual mathematic and theoretical operating of these lines, what their characteristics are, and what have you. So everything is very practically orientated. And no one's ever really done any of this stuff before. So the academians, and particularly the parasitic physicists that feel that they've stolen electricity and managed to turn it into some physical abomination that does not represent electricity at all, that's finally been overcome, and stuff that you will never find in any engineering textbook now is available in a very simplified form. So I'm gratified that I finally accomplished this. It took roughly 18 years to do it. And of course, it's built upon about 40 years of my mathematical experimentation, which was started by me in 1978 under the pressuring of my friend Philo Farnsworth to begin to engage in this project. Now, as far as the situation here, the materials are all on hand, and for the most part, and the necessary labor is minimal to get the rest of the pole pair up, to get a decent match of impedance between the electrostatic sensing of the pole pair as an antenna to the input of the amplifying apparatus. So the pole pair will be 4,800 feet long, and that will bring it down to the 15,000 ohm impedance level, which then can be applied to the first stage 37 Bravo on a bridging format. So the 37 Bravo bridges at about 80,000 ohms. So basically, there'll be an excellent conveyance of signal from the aerial into the first 37 Bravo, which then will convert from the unbalanced mode of ionosphere against ground to the balanced transmission line mode, which then goes to the shack. And there'll be another 37 Bravo, which will amplify that to program level, which then, which is yet to be determined, a reliable, very reliable radio link, probably AT&T, out of the shack into the internet. Now, once this thing gets done, there's going to be two things here that thus far nobody else has really accomplished, because they're dealing with little portable devices and what have you. Nobody has the correct value for our entire right of way from the shack to the terminal point in town is 3 miles. So we have 3 miles to work with here. Basically, 4,800 feet of that 3 miles is antenna structure, and then the rest is transmission lines to carry stuff around. So what we will have here is, first of all, is up to this point, what you're hearing coming out of the speaker on the devices that are available to the public is not really what's happening, because these impulses have extremely rapid rates of change and incredible peak amplitudes, and they cannot be amplified by conventional amplifiers. So what happens is you get all this snapping and popping and crackling, which originates from lightning discharges in a radius of anywhere from 200 to 2,000 miles, depending upon what initiates the discharge, whether it be typhoons versus thunderstorms or what have you. You hear those sounds coming out of the speaker, but those are not audio signals. They're radio frequency signals. But they have such an intense magnitude that they cause intermodulation distortion in the first stage, which then turns them from inaudible signals into audible signals, but those are not the signals that you want to listen to. So you end up with about 20 dB over the signal level of all this popping and crackling and what have you, and you can't hear the signal that you're actually trying to get at. That will be eliminated in this case, just like it was at Landers. It'll be much quieter, so it might be boring at that standpoint, if there isn't this cacophony of crashing and banging and tweaking and all that. But you will hear the signals, the voice frequency signals that we are after, with a very high level of fidelity and no intermodulation distortion. And this is something that has not been done in the public venue, so to speak. So it's all technically feasible. The one obstacle now of getting this to the point that it isn't something we turn on for a day and make measurements with and listen to, but in order to get this thing on the internet, first of all, we have to install another solar DC power system in the shack of plus 24 volts for the RCA Navy type of equipment, ham radio type of equipment, and the negative 24 volts DC for the Bell Telephone Western Electric type of equipment, like the 37 Bravos. So that will cost a considerable quantity of money, which we do not have. So that's the holdup. And then the monthly fees for the radio link and what equipment is going to eventually be required for that is still somewhat indeterminate, but that probably will not be cheap, even though it seems like we're on our way to that. But then that requires more cables going through the RF bulkhead and most likely another mast to hold that antenna up. So all these things get quite expensive, and roughly $10,000 are consumed per episode, and the people involved in the episode are often not paid or underpaid, but there's just simply no way to pay people a conventional wage on this type of stuff with the amount of money on hand. So basically, when $10,000 is received, then that can push a certain amount of stuff forward, but with the increasing labor costs and the cost of materials have just become absolutely insane. It's starting to look more like $25,000 per episode. So that is a significant obstacle in getting this on the air, as it just simply is not the money. But we do have all the materials for the most part, and it's all engineered and everything will work. The other project, the other goal, so to speak, besides getting the Earth ionosphere signals audible on the internet, is the telluric beacon transmitter. So the big complication with that is, even though the telluric platform is all established and the conduits in, and we have the means to put together a 100-watt transmitter, we have not overcome the RF, what you would call the electromagnetic compatibility problem, because of this thing is a monopolar longitudinal transmitter. It gets into the wiring in the building and all that. So we have to put in the isolation transformers. There's really no workable wiring in the building anyway. There's a total of 3 outlet circuits, and that's it, which are all loaded to their capacity. So that's about another $15,000 or $20,000 project to get the isolation transformers in, put in all the conduit, pull all the wire, all the grounding and all that kind of stuff. So basically, why we can transmit temporarily with the telluric beacon transmitter, we will not be able to most likely keep it on the air because of the interference complications, even though some shortcut methods may allow that, but nothing above 100 watts. Now, this system is conceived to operate at 1,000 watts, and there's just simply no way that that will be possible without the proper electromagnetic compatibility considerations. So the unfortunate reality is that in order to really do this in a timely manner that will be completed in my lifetime, or even shorter, the lifetime of this society, which is predicted to end within a year, we have to have $125,000 in the bank. And that just simply isn't forthcoming. And I don't see it to be forthcoming. So we'll do what we can, and we'll document what we can, and we'll try to get on the air what we can, maybe even if it's just briefly for like a week or something. But that's basically where we're at now. So I think that closes up our presentation, and then we're open for questions.
Okay, we'll have to get this wrapped up here sometime soon. If anybody does have questions, there is a reactions button you can click, and then you can click raise hand, and that'll let me know that you have a question. So if anybody has any questions, right now is the time. Okay, AS, go ahead and say where you're from, what your name is, and who your question is for, and your question, and please keep it relevant.
Okay. Yeah, my name is Arvin. I'm currently in Ottawa, Canada. My question is for Eric. I'm wondering what the magnitude of the electrostatic potentials between the ground and the surface, like I'm just wondering what, like, is it like 1 volt, or is it like thousands of volts?
It could get up to a couple hundred volts. In fact, in lightning situations, it can get even more than that. So there has to be protection devices.
Okay. I want to keep.
So basically, we're operating over a dynamic range of about 120 decibels. That's 10 with 12 zeros after it. So that's kind of the complication we're facing. So we have, at some point, we have to use AGC, automatic gain control amplifiers, and what have you. There is a whole amplifier, vacuum tube amplifier system that is designed to do all this stuff on the theoretical end, prototypes and all that. But that is just not feasible to install right now. I'd have to have, somebody have to be like, I would have to have Griffin here for 2 months to build all that stuff. And then there would be the cost of interfacing the power and all that. So we have to try to keep the signal level within the range of 10 microvolts to 1 volt. And that should work out okay, other than in major lightning considerations and hurricanes and things that generate massive signals. And there's pretty much no way that we can keep the system linear past that point. So that's kind of the initial problem right now.
Okay, and I'll contact Aaron to help with transcription, because I also published my own book, and I'm getting my electrical engineering degree right now, so I can understand at least half of it, I think. So,
well, if you're getting electrical engineering degree, remember that there is no more electrical engineering, and your head's just going to be jammed full of shit.
oh, I know. My dad
there's a
used
way
to.
out. There's a way out. There's a way out. Okay, it's Steinmetz. Is you can learn more by reading the first 10 pages of each chapter of Steinmetz's books than you will learn in the entirety of your electrical engineering course.
Yeah, my dad used to work for Bell Labs, so it's more of like a math exercise when I take my classes. So,
Yeah, it's basically just to fill your head with useless mathematical crap. It's kind of like a rite of passage, like the Indians would do. You'd have to go out, and catch a mountain lion, and maybe you get eaten, and maybe you won't. But you come back with scratches and tooth marks. But it didn't really do anything as far as other than satisfying some kind of anthropological ritual. That's all that mathematics is. It has absolutely no use in practice whatsoever.
yeah, that's been my experience as well. So, great. Thank you.
Okay, thank you. Let's see if anybody else has a question. Go ahead and click on reactions and click the raise hand button. If there are no more questions, then I guess we'll go ahead and wrap it up. I do see a question in the text about Stan Myers, but that's too off topic for this call. Please go to ericpdollar.com/donate to donate by PayPal or by check or money order to help support EPD Laboratories, Inc., which is a 501c3 nonprofit corporation. So all donations are tax deductible. And we'll talk about, I'll put a message out when we're going to be having a next live call, maybe here in a few weeks. Austin, I'm not talking about Stan Myers on this call, where this is about Tesla, the Long Lines project, the telluric stuff. Okay, so it's inappropriate to push it, and that's all. I'm not a gatekeeper of knowledge. I'm a moderator on a call for EPD Labs, and Stan Myers has nothing to do with EPD Labs. Okay, none of the work going on has anything to do with EPD Labs. If you don't know about Stan Myers creating ammonia fuel on demand, you can go read my blog post at emediapress.com. Search the blog for Stan Myers and what he was actually doing. Okay, and then there's your answer. Is longitudinal instantaneous because Faraday tubes need time to reshape and connect?
That's still kind of indeterminate. It appears to be that there's no velocity at all. It's another type of propagation, which I define in my presentation, electrical transmission in multiple coordinate systems. So it's not in miles per hour, but it's in per mile hours, as far as can be determined theoretically. But all of that is still theory. So basically, at this point, it's mainly just signal acquisition and putting something together that works and not getting wrapped up in a lot of theory, because that really doesn't help with anything. The theories all come later down the line.
Yeah, and as a note, what's going on here with the telluric ground transmission, listening to the Earth signals and all this kind of stuff doesn't have anything to do with free energy.
No.
That's completely off topic. Do geostorms interfere with this work?
They're what generate the signals. That's what we're after.
Because Thomson also considered radios as Hertzian, where tubes form closed loops.
Well, in this case, the tubes are not forming closed loops, they're open between the ionosphere and the Earth. So if we stick a capacitor plate in between, which is the aerial, then we intercept some of those lines of force and then divert them into the receiving equipment. So whatever lines of force emanate from deep inside the Earth out to the ionosphere, or whatever lines of force emanate from the ionosphere deep into the Earth, that is what we're taking a sample of and then processing as far as gain, interference, and distortion reduction, and then transmitting that out to the subscriber.
Okay. The more distance you send through longitudinal, the more voltage you need?
That's kind of a rough way to put it. It's more power you need. So because you're transmitting power, you're not transmitting voltage.
We'll keep everybody posted when the next call is. And thanks for everybody being on the call. Thanks for all the slideshows, Griffin, Haka says, and all the details from you, Justin, given the more comprehensive overview there. And we'll go ahead and call it a day. So hope everybody enjoys your weekend.
Thank you.
Thank you.
Okay, take care. Thanks, everybody.
Okay.